All right, I want to start out with kind of an abstract example, which I hope doesn't confuse you, but I don't want to get specific just yet about telling you formulas for different kinds of potential energy. So we're just going to do a kind of abstract problem where I give you the potential energy that you're working with, and you have to go from there. Okay, so in this problem here, imagine that maybe you're doing a lab, for instance, and you're studying some system. You have no idea what makes this system tick, but you have an object which is moving back and forth in the z direction. I don't know why I picked z, but let's say that it's moving in the z direction. And I take some measurements, and I eventually figure out that the potential energy of this object as it moves back and forth on the z-axis is 500 joules times meters over z, which, by the way, capital J is joule. That is the SI unit for energy, which I don't think I said in the previous videos. But anyway, so the potential energy is 1 over z times a constant number. And let's say that I release the object from rest at z equals 10 meters. Question number 1, which way is it going to move? Does it fall in the plus z direction, or does it fall in the minus z direction? How can I figure that out from the potential energy? And then question number 2, how far would it have to go from z equals 10 meter before it had a speed of 2 meters per second in whichever direction it's going? All right, so first of all, which way is it going to go? The way that you can figure this out is the fact that kinetic energy cannot be negative. I mentioned that in previous video. And the object is being released from rest, which means since it's being released from rest, it has no kinetic energy initially. Now, since its kinetic energy cannot be negative, there's only one possibility. As it starts to move, the kinetic energy is going to go up. So final kinetic energy is definitely going to be larger than 0. So it gained kinetic energy. If the object gained kinetic energy, that means that it had to lose potential energy. So the final potential energy should be lower than the initial potential energy. Because remember, the conservation of energy idea means that the total amount of energy has to remain the same. So if the kinetic energy went up, the potential energy had to go down by the same amount. So the potential energy went down in this process. So now, when I look at that formula for potential energy, which way would it have to move for the potential energy to go down? If z increases, the potential energy goes down. If z decreases, the potential energy goes up. So that means it's moving in the plus z direction. It moves in the plus z direction. Again, I'm basing that on the formula there, the fact that it's 1 over z. Like, if you don't believe me, plug in z equals 10 there, and then try plugging in z equals 11, try plugging in z equals 9. You'll see that if you plug in z equals 11, the potential energy will go down. If you plug in z equals 9, potential energy will go up. So we want the potential energy to go down here. So it's got to be moving in the positive z direction. Okay, so now I know which way it's moving. Now the quantitative part of the problem. I want to actually use the conservation of energy procedure. So first thing I need to do is identify what's the system I'm studying. It's this object. That's pretty self-explanatory. What are the types of what are the types of energy that I need to keep track of? As I've already indicated here, I need to keep track of kinetic energy, and I need to keep track of this potential energy formula that's been pre-cooked and given to me in the question. Then where things really get started here is I need to sketch the initial and final states. So let's make the z direction go this way, because that'll just be a little bit easier for me to draw. So that's going to be the positive z direction, will be to the right. So the object is going to start out, let's say that this point here is z equals 10 meter. So the initial state, the object is going to be here at z equals 10 at rest. So that's my initial picture. Then my final picture, the object will have moved a little bit in the positive z direction, and now it's going to be traveling at v equals 2 meters per second to the right. And what I don't know is, what is this final z coordinate? What is that unknown final z coordinate that it ends up at? Okay, so there's my, I now have a picture of the initial state and the final state in my mind. The next thing I need to do is write down either a number, or it might be an algebraic expression for the energy in the initial state and the energy in the final state. So for the initial state, I'm going to have, you have to do kinetic energy and potential energy. So the kinetic energy in the initial state is 0 because the object is at rest. The potential energy in the initial state is not 0. It's given by the formula that was given to me in the question. So it's 500 joule times meter divided by 10 meters because z equals 10. And meter cancels out meter, and we end up just with 50 joules, positive 50 joules. So the system starts out with 50 joules of energy, 0 plus 50. Now in the final state, I'm going to have final kinetic energy. I have to use the formula. I'm going to have half mv squared is the formula. So m is 2 from here. So I'm going to have 1/2 times 2, and then the velocity is also 2 from here. So 2 squared. So 1/2 times 2 times 2 squared, I can do that in my head. That's 4. So there are 4 joules of final kinetic energy. For the final potential energy, it's not going to be numerical. That's going to be an algebraic expression that has my variable in it. That's going to be 500 joule time meter divided by my unknown final z coordinate. Now, I'm going to need to make some space here. Get rid of some of this. We don't need that anymore. Okay, now we set the initial energy equal to the final energy, and that means total initial energy equal to total final energy. So the total energy is simply the kinetic plus the potential. So we're going to have 0 plus 50 is the initial energy. That's a J. And the final energy is going to be 4 plus 500 over Z. Okay, so we end up with 46 equals 500 over Z. So Z equals 500 divided by 46 meters, which is, calculator here, 500 over 46 is 10.87 meters. And you'll notice, as expected, I got an answer higher than 10 meters. I was expecting that it was moving in the positive Z direction, and my quantitative answer does confirm that. So the object moved by 0.87 meters in the positive Z direction is my final conclusion. So I hope that problem wasn't too abstract for you, because I didn't say what this potential energy actually represents. but I didn't want you to get too hung up on having one formula that you're always using for potential energy. So the next thing we'll do is talk about some specific types of potential energy and how you go about calculating.